In this video, we'll see how to use the slope formula in order to calculate the steepness of the line without the graph. The focus of today will be on positive slope. On the coordinate plane, we said that the positive slope is represented by a steepness of the line pointing upward to the right. So the line has two ends. The focus is on the right hand side, pointing upward to the right is positive slope. Today we'll be using the slope formula. Slope is represented by lowercase m. When we see m will be in the equation, that will stand for slope. To calculate slope, we need the vertical distance divided by horizontal distance, or the ratio of y difference over x difference. In formula form, that is looking like subtraction of the y coordinates that you have and subtraction of the x coordinates of 2 points. So you need 2 points to calculate the slope. On the numerator we subtract the y coordinates, on the denominator we subtract the x coordinates. That is a vertical distance divided by the horizontal distance. So positive slope on the graph should be pointing up to the right if we follow the line, and plotting the points xy order 4, 7, xy 0, 1, xy -4, -5, and then -6, -8. By connecting the points left to right, all my points are on a straight line, and towards the right hand side the line points upward, so I have a positive slope. To calculate the ratio, we look at any 2 points and find those ratio rectangles. This was reading the slope for the coordinate plane and visually reading the ratio where we can count the vertical and horizontal distances. For instance, between the closest 2 points I have 3 to 2, so the slope is positive, 3 by 2. Between the farther 2 points I have the ratio of 6 to 4, vertical to horizontal, and that simplifies to 3 to 2 as well. And then between these 2 points the ratio was 6 to 4, which simplifies to 3 to 2. So 3 to 2 positive, that was the reading from the graph. So slope is positive, upward to the right, either 6 to 4, which is the reduced fraction of 3 to 2. What we need is 2 points in order to use the slope formula. So for example, out of the 4 given points, I can use any 2. So I'm going to start with just picking. So let's say the first 2, 4, 7, and 0, 1. Without the graph, we can use the slope formula, where on the numerator you subtract the y coordinates. So we're going to take the y coordinates, 7 and 1, and we're going to subtract them. So 7 minus 1. And then on the denominator we subtract the x coordinates. So those are 4 and 0. So 4 minus 0. So the y coordinates, 7 minus 1. X coordinates on the denominator, x minus 0. 7 minus 1 is 6, 4 minus 0 is 4, 6/4 is positive, and it reduces to 3 over 2, which is the same slope as we had through observations on the graph. Let's see another 2 points just to prove that the slope is going to be exactly the same throughout the line. Doesn't matter which points we pick. So let's say I'll pick the last 2 points. So -4, -5, just so we can see an example with negatives, and -6, -8. So those were the 2 points here, -4, -5, and -6, -8. That was this ratio representation between the 2 points, which is 3 over 2 positive. But let's see how formula works. So the y coordinates are subtracted on the numerator. That would be -5, and we're subtracting -8. So when you subtract, make sure that the coordinates are placed in parentheses, the negative can be seen and the coordinates can be seen. So careful when you subtract negatives. And then x coordinates on the denominator in the same order as you subtracted the y coordinates. So 4, -4, and we subtract -6. Again, they're both negative, and we're subtracting. -4 subtract -6. -5 minus -8, that's -5 plus 8, which is 3. And -4 minus -6, which means -4 plus 6, that will be 2. So our slope is 3/2 positive through calculations rather than you look at the line and see the ratio. Either way works. Let's see why the slope is needed to be calculated both ways, either a graph or formula. So in the next situation, let's say I don't have a graph, but I have a word sentence that states that the slope needs to be found between the 2 points, -2, -1, and 2, 5. So if the coordinates are small like this, the best option is to probably use the coordinate plane. If the coordinates are small, I stay right here. One option is to plot the points on the coordinate plane and find the slope by counting. Counting is easier, and the ratio of horizontal to vertical to horizontal distances. So you would draw yourself a graph, you would plot the points, you would connect these 2 points and follow the directions of the line, which in this situation we have upward. Upward to the right is positive slope, so direction of the line is up to the right. Up to the right is positive slope. Then we need to see the ratio, which is represented by vertical to horizontal distance from point to point. Now we have vertical count 1, 2, 3, 4, 5, 6. Horizontal count 1, 2, 3, 4. That could be simplified to 3/2 by dividing by 2. This ratio has to work through the line. If you go from point 1, 2, 3/2, you're on the line. 1, 2, 3/2, you're on the line. So that ratio works twice from point to point of the bigger rectangle. Another option is to use the slope formula. When you use the slope formula, you don't need to draw the graph. What you do is use your 2 points, -2, -1, and 2, 5. Those are the 2 given points in the problem. On the numerator, you would subtract your y coordinates, which are -1 and 5. On the denominator, you would subtract your x coordinates in the same order, so that means -2 and 2. When we subtract the coordinates, careful with the integer rules. So -1 minus 5, that means add the numbers, keep the sign, -6. -2 minus 2, add the numbers, keep the sign, that would be -4. In simplifying fraction, negative divided by negative is positive, and then division by 2 results to 3/2. So that slope is the same whether we look at the graph or we use the slope formula. To find the slope between the 2 points when the numbers are big, this is when the formula is efficient, because when the numbers are big, you would not draw them on the coordinate plane and then count how much is the vertical and how much the horizontal distance. So when it comes to big numbers, graphing is not the best way to find the slope. However, a sketch can help identifying the direction of the line, which at least can help with the sign of the slope. And then estimating or working with the numbers become a little bit easier. So to plot the numbers on the coordinate plane, we're going to use a sketch. So the approximation. So I'm going to use dashes for tens. So I'm going to go 1, 2, that would be like 10, 20, 30, 40, 50, 60, 70, 80. 90, let's say, because my x value here is 87, so I need to go up to 90 approximately. Then I'm going to go up for y, 10, 20, 30, 40, 50, 60, 70. And then for negative, negative 10, negative 20, negative 30, some kind of sketching, so close approximation. Here I have negative 12, so it will be like negative past 10 a little bit, and then 30, so I have to go 10, 20, almost 30, so approximately over here, negative 12, 28. Second point is 87, 62, so I have 10, 20, 30, 40, 50, 60, 70, 87, close to 90, let's say, and then up 10, 20, 30, 40, 50, 62. So let's say here is 87, 62. So this is again a sketch representing approximate location of the numbers, and what that helps with is the direction of the line. Direction of the line is positive, so at this point, all I know that my slope has to be positive. So when I work with the numbers and I have a negative slope, then I can see where my mistake is. To find the slope between 2 points with large coordinates, the best way is to use the slope formula. So we have xy first ordered pair was negative 12, 28, and the second 87, 62. On the numerator, we would subtract the y coordinates, 28 minus 62. On the denominator, we'll subtract the x coordinates, negative 12 minus 87. So to subtract, we want to use integer rules. 28 minus 62. 62 is bigger, so the answer will be negative, and then subtract. Negative and negative, we add the numbers, keep the sign, so it's still negative, and then 99. In simplifying fractions, negative numerator and negative denominator, negative divided by negative will be positive. And in this situation, we cannot simplify the numbers, so this would be our slope value. Positive, which is matching with the orientation of the line up to the right, and then 34 over 99 would be this ratio of vertical over the horizontal distances. To find the slope from graph, where the graph is given, the ordered pairs are not, we want to read the points. So by carefully analyzing the scales and the direction of the line and the location of the points that could be read off the line, we need to read 2 points. The more points you read, the better it is for accuracy, but to calculate the slope, all you need is 2 points. So I'm going to go carefully throughout the line and see what points or which points can be identified, and just pick any 2 that you prefer. So let's say I have a few points here, and I have 2, 1, I have 3, 3, I have 4, 5, I can read 5, 7, I can read 6, 9. So just pick a few. You don't have to pick a lot, but what you need to see is the consistency. So observe the rate of change, and to be a consistent number of the vertical to horizontal. Then, to calculate the slope using the slope formula, all you need is 2 points. Which 2 points you pick doesn't matter. So let's say out of my chart, I'll pick first and last. So xy, I'll use 2, 1, and 4, 5. I just pick which ones I want. On the numerator, subtract y coordinates. On the denominator, subtract x coordinates in the same order. So if it's 1 minus 5, it has to be 2 minus 4. 1 minus 5 is negative 4. 2 minus 4 is negative 2. In simplifying fraction, negative divided by negative is positive, and that would reduce to 2 over 1. So for every 2 up, there is 1 square across, or for every 2 units up, there is 1 unit to the right in this situation. And that can be same as 2. So 2 over 1 or 2, which is the ratio is 2 over 1. Another number or example for the scales, again we are going by tens, so first you want to make sure that you pay attention to the scales when you read the graph, and then to find the slope you need to identify a few points. How many? You only need 2. But when we identify the points, if you identify a few, you can start observing the ratio and the consistency of the vertical to horizontal count. So first, upward to the right, we have a positive slope. Then we need to read a few points in the coordinate plane to put in the chart. So I have 3 here. You can list all 4. 0, 30 is my first point that is showing the intersection with the y-axis, 0, 30. And then 10, 50. And then 20, 70. And then you have 30, 90. So you can use as many as you want, as long as they are something that can clearly read from the graph. For slope calculation, all you need is 2. So you need to pick 2 points. Which ones doesn't matter. So I'll pick, let's say, 0, 30 and 10, 50, first and second. Why not? Y difference is subtraction of y coordinates on the numerator. X difference is subtraction of the x coordinates of the denominator. So y difference over x difference. Y is vertical count, x is horizontal count. In the slope, the ratio is vertical to horizontal. 10 minus 50 will be negative 20. 0 minus 10 will be negative 10. In simplifying fractions, negative divided by negative will be positive, and I can divide by 10 to have the ratio 2 over 1. So my slope of the line, or the tilt or inclination, is positive and 2 over 1. For every 2 units up, there is 1 across. Or for every 20, there is 10, which was the ratio simplified 2 to 1. If I look at graph, I have 10, 20 over 10. From 30 to 50 is 20 over 10. And that simplifies to 2 over 1.